Hey folks, and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology professor, Jen. And today, from Monday's Musings, we're going to talk about the geography of the Morrison Basin. So there's three things I want you to get from this. How do we know what the Morrison Basin looked like? How do we know that it was a basin? And recognizing that there were different environments within this basin. Okay, so first and easiest, how do we know that the Morrison Basin was a basin? Well, it's easy. Because the rock record only records depositional environments. And deposition happens in topographic low relief areas. Topographically low relief areas. A basin. Or a lack thereof. We can extrapolate where the highlands were from fluvial deposits and where we find them, i.e. where the conglomerates versus sandstones versus mudstones are in the fluvial system. So here I sketched out a very simplified diagram of the mountain to the ocean in profile kind of thing. So as you look from left to right, we start with our conglomerates in the mountains, and as we go downhill, we go to coarse grain sandstone, medium grain sandstone, fine grain sandstones that are beach, limestone, and then shale in our basin. This is obviously very, very simplified. So our fine grain sediments are going to be in places of the least amount of movement, which are our basins. Now, how do we know what the land looked like? Well, we can find the answers in the rocks again. So we're going to start up north in Canada. So in Canada, the Morrison Formation is not used, but there are equivalent rock layers. We have the Fernie Formation, which is shown here, the Morrissey Formation, and the lower part of the Mist Mountain Formation. So we're going to go through each of those just to give you an idea. So the Fernie Formation is primarily made of shales with a few sandstones, cherts, and limestones. And even in here, you can see a little bit of that going on. These rocks tell us that this is where the Sundance Sea was during the last part of the Jurassic period. So, our shallow marine seas. That was very redundant. Marine obviously implies seas. Our shallow, warm shallow seas is what I meant to say. Next we see the Morrissey Formation. Yeah, Morrissey. Not Morrison, Morrissey. It's primarily made out of conglomeratic sandstones with rare beds of mudstone and siltstone and even coal layers. So this indicates a deltaic, nearshore, or littoral beach environment. And the coal implies that there were swamps along this shoreline, kind of like we see in Florida right now. This formation basically is showing us where our rivers were emptying into the Sundance Sea from the highlands. So our conglomerates are coming from the Sevier orogenic belt, so basically Sevier Mountains, and emptying towards the sea. Next we have the Mist Mountain Formation, which is actually rocks. These rocks actually straddle the Jurassic Cretaceous boundary. It is primarily shale, siltstone, sandstone, and mudstone. This formation represents fluvial channels, floodplains, deltaic and coastal plains with swamps along the western interior seaway as it began to transgress back across the continent. So it's similar to the last one, but it's starting to go back the other way. Now, as we move further south and we move into Wyoming and Montana, we can see the environment start to change a little. The base of the Morrison here is the Windy Hill member. It's a limey fossiliferous sandstone indicating a warm shallow seabed, not unlike the Gulf of Mexico. This is the extent of the Sundance Sea in the late Jurassic. By this point in time, the sea was starting to regress off the continent, heading towards northwestern Canada and the ocean. We see a little bit of the Windy Hill in northern Colorado and northern Utah as well, but it's primarily in Montana and Wyoming. The Windy Hill is white beach sandstone. As you can see, the sandstone that I'm sitting on is white beach sandstone. The picture below depicts the Gulf of Mexico, one of the shorelines there, white beach sandstone. So we can get a fairly good idea of what the Windy Hill shoreline looked like. Sitting on top of the Windy Hill in some places is the Swift Formation. This is also a marine deposit of primarily orangish brown glauconitic sandstone. This is a picture of a piece that I picked up from northwest central Montana, up by Shoto. This has some plant remains in it, so that's the black. You're seeing the carbonaceous palm fronds. But you see the orangish brown and the glauconitic sand that it's embedded in. This formation is commonly filled with fossils, as shown here, and the deposits that we were finding were just plumb full of plants. It was a lot. The Swift Formation was showing shallow marine and coastal deposits with forests along that edge there, kind of like we see in the Pacific Northwest now. So very similar to that. But in other places, the Swift Formation is capped by more Morrison and other things. Lots of interfingering going on. And that Morrison Formation proper, you can find in central Montana. You can find it in Livingston and other places like that. And it's going into the Bighorn Basin in Wyoming and things like that. This Morrison consists of the typical variegated mudstones and the channel sandstones with the minor limestone lenses that indicate that the environment was changing from this coastal to more fluvial and lacustrine deposits. The biggest difference with the Montana and northern Wyoming Morrison deposits from the typical ones that we know of on the Colorado Plateau is that there isn't a clay change. So the clay starts as this illite based clay and then changes into smectitic. But there's almost no smectite in Montana or northern Wyoming. So there isn't a clay change, which means there's no volcanic activity happening up north. But as we continue to move south through Wyoming, the Morrison continues to have that typical variegated mudstone that we see below me and the sandstone profile. However, a 2010 paper noted that it was mostly lacustrine or lake deposits rather than fluvial or river deposits. And the basal Morrison in Wyoming, as mentioned before, is the Windy Hill, so perhaps the lakes were what was left over after the Sundance Sea had retreated, and that's why it was a little wetter. Next, we move to northern Utah and Colorado, which are very similar to Wyoming with slightly more fluvial rocks, as what we're digging in here at our Evil Tree Bone Bed. I know, shameless plug. Come dig in our Morrison fluvial environment with CNCC this summer. I'll tell you more later, but check out our website, cncc.edu/paleontology-summer. Woo. Anyway, this is where the clay change starts to show up, though, in Utah and Colorado. We definitely have layers of smectite around us in our mudstones, both above and below us, but we do also have the more illitic mudstone below us as well. So we know there was volcanic activity happening in northern Colorado and northern Utah. And as you can see from a modern example below, ash really chokes the river system and makes things sticky. As we continue heading south, things get more seasonal with our dry and wet seasons, and we start seeing primarily fluvial sandstones and conglomerates along with our smectite. Down by our Three Corners area, we actually have deposits that show an extra saline lake like our Great Salt Lake called Lake Tuadichi, I believe that's how you pronounce it, which shows it was incredibly arid down there and not really good for sustaining life. And as well as down south, in South Dakota, we also have sandstone deposits that show Aeolian dunes or deserts. So to put it all together, this is North America in the late Jurassic.